Hello, good to be here after a 2-year pause. I had so many good talks already with people I know from previous conferences, met a lot of new people. Today, I would like to talk about ScriptBlocks, which is an experiment because we are at PowerShell Conference EU, which is like a level 400 thing. You're all gurus, and ScriptBlocks have been around since 2009. What I did was compiling everything I have about ScriptBlocks and put them in some order that makes sense. And I would like to just present that to you in a meaningful way and see if there are maybe gaps that we can fill. Also, I've seen lots of colleagues came to this conference, some for the first time this time. Maybe there's something I can pass on to you and give you some inspiration. I have VS Code, I have ISE on my machine, and I was kind of a little bit sad when in this previous talk there was this question, are you using VS Code or ISE? And when some hands went up still for ISE, there was this view, hey, you're still using ISE? ISE is a great editor, really, and I would like to present on both editors just for the fun of it. To me, it's like with any handyman, when you have a tool set, you don't have just one screwdriver, you have many of those. And I always use both. I use VS Code when I have different file types or greater projects. And I use ISE when it is just a simple PowerShell script. Okay, so ScriptBlocks is about code isolation. Just first things first, the round parentheses is about executing code immediately. And when you use these curly braces, you want to execute code not immediately. That's basically the idea behind these ScriptBlocks, the lower thing, the script block. And now, when you look at PowerShell code, you find them everywhere. When you look at it more closely, you can see ScriptBlocks allow you to run code now, which kind of makes no sense at first, but it does make sense. We'll look at that because you can normally run commands without ScriptBlocks immediately. You can run them later, which is what most of us do. You have a script block, and then you take this keyword function and just glue a name to that script block. So you have a named script block that you can store away in a module if you want to. But also PS1 files, scripts are script blocks. You don't see curly braces in your script files, but by definition, when you load a PS1 file, that is treated like a big script block, which is good because anything you learn here or you knew before applies to functions, applies to scripts, applies to delegates as well. You can run script blocks elsewhere. That's the foundation of remoting. Invoke command is the beaming platform of the enterprise. You beam your code away to a couple servers and then they run there. And that's another very important use case, using them as delegates. Where object for each object, that's something we do daily, probably. And here it's different. Before I used the script blocks to define commands, and now I'm using script blocks on the user end. Now the user can submit a script block as an argument to a function. Now with where object, you're probably more than familiar, but as you can see down here, this is open to you as well. When you do tool building, when you create functions for your colleagues, you can also enable them to take delegates. And I'd like to show this here with this input box command. By the way, you don't have to write down anything. It's on GitHub. I'll give you the GitHub address at the end of this talk. So you have the source code of all of this, including show input box and all the other examples. So when I run this now, you'll see that this is code isolation for some GUI code. So I don't have to pollute my own code with GUI stuff just because I want some user interface. That's what this show input box command now is for. And at the same time, the script block allows me to provide as much control to the user as the user needs to shape this input box any way they want. For example, you can even relabel the buttons, but now maybe keep an eye on the delegate in the background. When I enter something, currently the send button is disabled. Now I enter my email address in case you want to drop a line. PowerShell. And now take a look at ON. Now it wakes up and I can enter another E. That's simply because here is the delegate. A delegate is executed not by you, but by someone else, just like with where object. And anytime a decision is necessary, that entity that runs your script block executes your delegate. And if that returns true, then things are okay. And if it returns false, things are not okay. Where object does the filtering this way, and input box enables this button that way. It's basically simply an argument of type ScriptBlock. Don't take type int or string, take ScriptBlock, and then you can evaluate the ScriptBlock yourself. Okay, let's go on. Here is an attribute. Attributes are commonplace, basically. We use them often in functions for mandatory parameters. When you compare the syntax of an attribute, it's almost looking like a type. This would be a data type. It's a word in square brackets. And the string. Okay. That's why I brought this keyboard, actually. Well, the attribute has, in addition, round parentheses here. It's like a wish list, basically. And this is the name of the wish list, and then these are your wishes. And here you see, again, a delegate. Most people use attributes just for param blocks, for functions, to define the arguments and parameters. But that's just one use case. After all, in functions, parameters are simply variables. So you can use that with any variable you want. Here, for example, I have a variable in my script. It's completely outside any param block. And string isn't enough for me. I want this variable to just be valid with a valid path. So the validate script attribute is attached to this, and you can now see what happens. This works, and now the delegate, the script block, is not executed by you, but by the setter of the variable. Whenever you now assign something to the variable, your code is executed. Now this works because this path is valid, and this one fails, even though it's a string. And when you think about this for a moment, what you can do with this is awesome. You can have your delegate always return true. This way, you can continue to assign whatever you want to your variables, but also add more code to this. So you can do logging or performance counting or something else that you want. Whenever something is assigned to that variable, you can do something. As a proof of concept, let's see if the sound works. Here's a special variable. It's called path, and it's a very friendly variable. When you assign something to it, it joins with a high beep. Let's see if that works here. Yeah, but if it doesn't work, if the path is invalid, you get a feedback immediately. So that's really interesting what you can do with these validation script. In any case, anything I did here was a script block. Oh yeah, there's another thing that you can do with script blocks, that's speeding them up. As you know, in PowerShell 7, you have now the parallel loops that are built in. So when you do a for each object parallel, they all run at the same time. But you can do that in Windows PowerShell as well, either by using this module from the gallery. Like we talked about that before, the gallery is full of useful stuff, or you'll get the source codes for that parallel loop in this GitHub. Then you can just do it without dependency. Now, when you look at this, these are no script blocks, even though they are curly braces. I just talked to Bruce Payette, and he knows, and he's authoritative. He programmed that shit. He said, yeah, if there is a keyword from the language starting the parser, then it is not a script block. Then it's simply a language construct, like a condition or loop. So these curly braces, they still contain just PowerShell code, but they're not valid. Now, script blocks can be used for all kinds of things, but the important thing, really, the strategy here is to think about your company, about your department. Because when you do not embrace script blocks, then you may have a script like this. You may have a 200, 300 line script, which works perfectly fine, and it's okay to use that. But 2 months from now, no one really dares to touch this anymore. And it's a great script. I ran it yesterday night in my hotel room. I'll run it again. It's a super fast port scanner, and I did not connected to our Wi-Fi, but to the hotel Wi-Fi. These are all people without firewalls. It's amazing, and it's fast. These were 700 IPs that PowerShell just scanned. Now, when you add script blocks, they are about code isolation, and that means the same code could also look like this. And I think you can immediately see that you have 2 advantages when you do that. One is, even from the management standpoint or audit standpoint, you can much easier understand what a script does, or you can much easier adjust it for a different IP region. But also, you can reuse parts of the time and effort that you put into your code. Here, for example, I have test port. Well, why not use it for something else? If I now say test port and let's say Microsoft, let's see if I get their website, port 80. What do I get? Yeah, it's open. So that is always good to componentize your code, to use script blocks and build functions. Ideally, and I've seen all the hands up when this morning someone asked, ideally build modules. I'm not going to go over every scripts that I have in this GitHub. When you download it later, you can find much more material, but I'm bound to these 30 minutes. The important part is this. A script block, like these curly braces, is always valid PowerShell code, because once you define this thing in your script, not run, but define, the parser is invoked. So whenever I would even try in any editors to add something that is syntactically invalid, like this, I get immediately these squiggly lines. That doesn't work. So that is the reason is, with a script block, you always have a ready-to-use, already parsed piece of code that you can send someplace, and it is very performant. But you can also access the script block methods. This is what I want to do here. I have any script block content. Don't focus on the content. It's just some code. And when I define this, I can now look at my variable, and you'll see you get back that script block object. Let me scroll this up a little bit. It's a script block object. Type script block, and there are all kinds of interesting methods in here. I could invoke it, okay, but I can also go to the AST. Now, AST is nothing new either, so please raise your hand if you frequently work with the AST. Okay, I added frequently so that not too many hands go up. But I wanted to show you just right now what AST is, and at the end you get another solution that builds on ASTs that can help you a lot with these script blocks. Now the AST looks like this. It's an object describing your script block, and it's very boring, but it does give you an indication that there are different components or compartments in your script block. You have a begin block, you have a process block, which are both empty, and you have an end block. So the AST proves the point that when you don't care about these begin, end, and process stuff, everything is in the end block. Okay. All right. Yeah, thank you. Let's do this again. Everything is in the end block. And that's okay. The end block, it doesn't matter in which block you put code if all you want to do is execute your script block once. But the moment you start to pipe in pipeline data, you need to be very careful about these blocks. If you call a script block just like that, then first the begin block, then the process block, then the end block executes. Again, it doesn't matter where your code is, but in pipelines, it's a little bit different. Before we look at that pipeline, here is a method that is very, very interesting, find all. It's part of that script block. And again, it takes a delegate. Delegates are everywhere. Script blocks are delegates. So this is a really dumb delegate. It always answers true. So this delegate, think where object. With where object, you have a delegate that decides which object can pass through. Here is the same thing. And when you say true, it's basically saying, give me everything. And the second parameter is for recursiveness. Let's see, take a look at the signature. First one is the predicate or delegate, and the second one is a bool about, do I want to go in this tree recursively? So if I do this, you see what you get. You get all kinds of data sets describing your code. And I don't want to dive too deep into this, but this is an awesome tool for all kinds of documentation or refactoring. So if I skip a couple lines and then just do this, let's take a look at the result. I know which variable assignments I have in which line, if that would be something I wanted to know about a script. What did I do? I asked the AST, give me not everything, but this time give me only assignment statements. And then I just want to know what's left, what's the operator, what's right. And again, a script block. This one you probably know. In select object, you always have the choice to say or to specify the column that you want to see, or a script block if you want to calculate something. All right, so let's move on to what you need to use script blocks to isolate code, to create more modular scripts. For this, I switch to VS Code. Okay, so we have seen both. This is the GitHub content that you basically get. And if you want to do code isolation, you need, let me show you this here. This is the GitHub that you will get. You need scoping, input, output. Scoping is really easy. Scoping means you have a built-in garbage collector. You do not in PowerShell need to free variables. That's done by ScriptBlocks for you. And it's done by creating a territory. So anything inside of this script block that is defined, this could also be a function or a script, is living in its own memory set. And when the script block is done, it's all put on the trash. So these variables here, my value, my result, my value, my result, even though they have the same name, they are not the same. These are different variables. They just happen to have the same name. They live in different territories. And that also explains the other call operator. When you do not want the scope, you can simply use the dot. That's dot sourcing. This way you get all the other features of the script block, but you actively waive the territory. I don't want the territory. Why would you do that? That is basically PowerShell's way of including files. And you see that in modules or anywhere else where you want it. So basically, if I would write a dot and a path to a script, this would be the equivalent as if the script code would be right there in my file, because there's no territory. Another thing would be a dirty trick down here. This is how people change the behavior of PowerShell functions so that they more or less resemble VBScript or JScript or something like that. Here, you only get back what you say after return. And anything else that you do not assign will be isolated. So I'm not. That's a different topic for a different talk. But ScriptBlocks are leaky, so anything that you do not assign will be going to your output. Now let's take a look at the input side. And we have seen basically a couple of magic variables, $_, args, input, this. These are all variables that can appear magically in your script block and you haven't defined them. They must come from someplace. And here, the upper part, that's the interesting part. This shows, oh, my wife, too late. This shows a couple of examples with script blocks. Here you see $args. $args is the built-in variable in which a script block surfaces all the arguments that you submit to it. So if you write a function and you don't care about anything sophisticated, you always have args. So let me just do that. Function A, args. So here's my function A. And I can now say test A, B, E, and these are my arguments. They surface in args. This is how PowerShell started in PowerShell version 1 and 2 also. And then when you are on this level of script blocks, you also have input. Input is the other way around. This one, args, receives from the right side as arguments, and input receives from the left side over the pipeline. So this is pipeline input. When I run this, I get the 10 numbers also. But the bad thing is you have two different variables. You cannot say I have one parameter input that works either as an argument or from the pipeline. I have to use these special variables. And the third one, that's also a pipeline variable. When I run this, you see the difference. If you look closely, input gets all the pipeline input in one chunk. It's one thing. You get the data after the whole pipeline is done. Whereas $_ gives you each pipeline element as it streams through the pipeline. So this is the real time. Let's just assume here's a command that outputs a number every second. Then you would see each second here a number, 1, 2, 3, and so forth. Here, you would have to wait 10 seconds, and then you would get all 10 numbers. That's the difference, basically. However, these ones are identical. And this also reveals that for each object doesn't really exist. It is simply a thin wrapper around a script block again. For each object is basically creating a script block, which is coincidentally the reason why, I have to start not with for each, why for each object has these parameters begin, process, end. This is basically how you define your script block. And here you see now that in order to process pipeline input in real time, that's why you need this process block. If you wouldn't use the process block, if you would simply put your code in the script block, then it would end up in the end block, and that's when the pipeline's already done. So if you want to have pipeline-aware scripts or functions or native script blocks, you need that process block. We'll see that in a moment. The way how these simple script blocks work is something that is actually still in production. If you use remoting within invoke command and you want to send something from your world into the remoting world, like a credential or something, then that's how it works. You have invoke command, you have script block. There is your script block that you want to execute remotely. Here is our args. You see, args are the arguments. And then invoke command has this parameter. This parameter is now specifying your arguments. So it could be a credential, could be a series of numbers, whatever it is. This is from your world. This one, your script block, is flying over to the servers, and the data is also flying over to the servers and then ending up here. Okay. Now, most of us are now today using param blocks. Like maybe raise your hand if you're using param blocks. Okay, almost everybody. And this is already, or this is another feature that you get for free from ScriptBlocks. It's a full-blown argument parser. So what it does is it takes that raw stuff that args received and then applies the way how PowerShell treats parameters. So in this case, I define two parameters. Okay, and now PowerShell can accept them positionally or named, like here. But in this mode where you only use a param block, you still have args. Args is the spillover. So anything that a user would add as arguments to your function or script block that doesn't fit into the param block would end up in args. So in this case, when I submit 1, 2, and then the spillover stuff here, I would get this in 1, this in 2, and the rest would go in here. Let's do that. And by the way, I'm executing those script blocks directly, but you could also say function test and call test. Let's do that and run it. And then you see the 1 went to 1, the 2 went to 2, and the more than it could eat, the spillover went to args. Now the last final control that you can get would be to add attributes. Once you add attributes, not every attribute, but two specific attributes are important. Once you either use parameter or commandlet binding, either one. I could also say commandlet binding, like this. This tells PowerShell to turn this simple function into an advanced function, which you can basically see when you run this function, that you now get the common parameters as well, like error action and verbose and all this stuff. Let me just do this. Okay, run this. So test. I don't have IntelliSense here. Shit, it's not easy. Okay, believe it or you know that it is that way. You now have an advanced function. Now you don't have args anymore. Now you don't have any of those generic variables that we just talked about a minute ago. Now you are in a strictly defined environment. Only the parameters that you specified are there and can be used. And if I would dare to, so this would work. I have a mandatory parameter. I wanted it like that. Okay, so I get prompted. Wonderful. Test. I can also, and this is the benefit, I can now use the same parameter both as argument or as pipeline input, because now I can declare them as value from pipeline. So I can also receive here, but I can no longer have spillovers or stuff like that. So if I submit more parameters than allowed, I get this error message. Now I have a strict parser. Okay. Here's something many people don't know. Be honest, if you tell me later on if you use this. We talked about delegates and that users can use delegates like ScriptBlocks as arguments, and actually you get them for free from these ScriptBlocks. Take a look at rename item as an example. That's a commandlet. It's isolated, so it's small but deep, so it can only rename, but that it can do good. So if I use it outside the pipeline, it's easy. This is the file I want to rename. This is a new name. Of course, I don't do it. I just simulate, and this is basically what I wanted. What if I use this commandlet in the pipeline? So I pipe all files of some folder, like the Windows folder, to rename item. I don't really want to all call them XYZ. So new name doesn't work anymore. Do you see the problem? Huh? New name is a string. And if I pipe in many, many files into rename item, then I somehow need new name to have a reference to what is coming in. Maybe I just want to add a different extension or a date timestamp or something like that. And that works magically. All these commandlets that accept pipeline input have delegate support, even though the parameter is typed as string. And so I could do this. Take a look at the difference. Let me just try and do this a little bit smaller. When I run this here, it's what if. As you can see, all these files now are called the same name. If I run this, I have added an extension old to all the file names, but they have kept their old name. And that's because we have the $_ variable again. So the streaming variable from this basic script blocks, $_ is the streaming thing. So each time a file goes through this pipeline, I have access to it, and I can use parts of its old name. Now let's take a look at how you can do the same thing with your own commandlets. Works for many different commandlets. Here's my function. And I want this function to also be able to access the incoming object. The requirements are two requirements. One is you need always something like this. You need always a parameter that takes happily the entire object that comes from the pipeline, value from pipeline. So I can reference it later. You can call it any way you want. And then you need the second parameter. This is the one that gets the delegate. That needs to have at least value from pipeline by property name. Let's see what's happening. These are the two requirements. Here's the function. Okay. I can receive pipeline data now. Works. I can receive data by property. Since the parameter is called some data, I can receive some data. Works. I can still use it as an argument. Works. And now to the delegate. When I pipe in lots of data, the parameter some data that is string automatically now has the ability to also use a script block. So I can take 10 numbers and multiply each number by 10 and it works. No, it doesn't work. No, it works. 70, 80, 90. Or I can generate this way IP addresses or something like that. So this is really, really easy to add to your functions. All you need to do is make sure you receive the entire object and make sure that your parameter that you want to have a delegate for has this attribute or this attribute value. Okay, so we were looking now at the input part, and the output part I don't have the time for, but it's on the GitHub. There's one thing I wanted to show you before we go into Q&A and then can decide if you want to do other things. That is production. Don't be afraid of dependencies. One thing that many people are afraid of is when they start creating functions and modules, that they suddenly have dependencies. Of course, when you ship a script and it uses functions that are actually coming from a module, then you also have to ship your module, which you might not want to do. At the beginning, I showed you the AST, the abstract syntax tree, which is built into every script block, every script, every function. It tells you the variables, that's what you've seen, but it also tells you the commands that the script has been using and where they come from, where they're coming from. So you can have a tool, it's part of this GitHub that works like this. Let's take this example and then we go to the Q&A. This is from the beginning, this fast port scanner. It has a dependency into this module, TW network helpers, which is also part of this GitHub. When I want to ship this without dependencies, if I really need to do that, let's see what we can do. No, I'm wrong. Internalize dependencies. Here is a simple isolated code block. Again, a function that does the dirty work for you. Import TW dependency. You simply specify the name to a script and out comes the script with all the internalized functions. So again, that you see that, no, this is for the dramaturgic effect. This is the script. No. Just let me build this up real quick. So we start with this script. This script is what I would like to ship to someone else. So this is the name of the script that I'm specifying here. And now I'm running this. Okay, something else ran. What ran? Let me see what ran. This is a nice thing about PowerShell. At the beginning, you always think that it personally wants to ICE. Oh yeah. Well, the IC is opened up. That's true. I need to close this. That's true. I wanted to show you can say Notepad as well. I just wanted to do it in IC. But oh, it's not there. Then let's take Notepad. Fine. Notepad is dead. And now you see what you get. All the functions that came from different modules or one module are now internalized into that script. You can pass on this one script if you want to. You do not lead the modules anymore, but you still have your code down here. But rather than, for example, get IPv4 segment, go to that module, it simply reads it from the function that is in here. The source code comes directly from the modules. And it also gives you the option strategically. Think about the monster script from the beginning. That is really hard to understand after a couple of weeks. If you do not like modules, at least you should aim to use functions, make them reusable and put them in your scripts. But even if you use modules, you can always come back to a script like this. And the source code or the function that I used here is basically using the AST of the script block. Okay, it's time for Q&A or for talking, so that is not only one direction. Like I said, this was an experiment. We weren't sure if we can, if ScriptBlocks could be anything new for you, or if you would enjoy the rehearsal of it. So I would open up the Q&A if you have questions or feedback.
I have one question. At the place where you renamed the files,
where I renamed the files, wait a minute, that was output, no, pipeline.
At the start you mentioned that in a scenario where you want to run code you use normal braces.
Here.
That in a scenario where you want to run code later on, you would use curly braces. In this case, I imagine normal braces will also work.
You imagine what? Normal braces? Which, here you mean? No. Okay, the question was? Yes, the question was, in this scenario, the curly brace, is that necessary, or could we also use parentheses? And that's basically a huge difference. If you would use normal parentheses, that is always code that is executed immediately. That is executed basically, yeah, well, I see your question. This piece of code is not executed by you. That's the important part, really. And maybe I didn't explain that strongly enough at the very beginning of the first slide. Parentheses is like in math only a way for you to control execution order if you have more than one command in a line. But it's still you who is executing this. in cases where you have curly braces, you always know that not you are executing the code, but instead you are giving this chunk of code to someone else. And that someone else, like rename item, inside of his own world is executing this. So dollar underscore, if you do parentheses, dollar underscore would be empty. Good question. Thank you. Any other questions or general feedback about the state of the script block? If you have no questions, I go on. Sorry. Because then there is also the output. And we should at least cover that then. Okay, it's your fault. You could have asked questions. Output is as important as the input. Let's take a look at the case of the leaky script block that I mentioned already. Here you see something you know, but many people that come from other languages to PowerShell are really confused about. That is the case of how a script block determines the return value, the result that the caller gets. So the function test here returns actually 3 return values as an array. Let's do that. Like this. 3 values that I got back. Count. And this is the array. This is actually something that you can actively use. If you know that a script block works like that, and that it can combine the output of many sources, then you can leverage this. Here is a use case. This would be a password generator. And this password generator takes characters from different collections, like capitals, numbers, special characters, and more. And here you see your cute script block. Here it is. And all we want from this script block is to be leaky, to take the data from all the different commands so that I can at one spot get back that array. Because I really want only characters from this, and this collection. Most people start with an empty array and use the plus equals operator, which is highly inefficient. It's still okay for a couple of numbers of items, but this is much more beautiful, of course. You don't have to do that, but you can. That's showing you, when you understand a script block, each functionality that it has, you can simply pick one, and this would be the leaky aspect of a script block. However, most people didn't like that so much. So let's take a look at what you can do. You have seen that the input, the civilized input, the politically correct input is always the param block. And the politically correct output is always 6 streams. Each script block has 6 streams. And that's the reason why you have so many write commands. Each write command goes to a stream. I have noted here the number of the stream. As you can see, there are a couple of ways how you can write to the output stream. You can use write output, but you can also just leave it unassigned, like here, then it goes also to the output. Or you can use return. But return is not the only way to write to the output stream. And then also I added which of these streams are visible by default, because some of those streams are hidden. And like you probably know, when you list the preference variables, then you can control which streams are visible. This is basically telling PowerShell which stream should be visible. Now let's take a look at what you can do in terms of logging. Let's see. Add streams to... No. Here's a nice example. The example is designed to show you how you can abuse the features of a script block. Let's assume your script uses write host for debug messages. Let's just assume someone did it this way. This is already better than simply putting the text into your script, because this way is a different stream, so you can separate it from the output. And when I run this now, I get my messages. It does something, there's a message, so on, so good. Now I'm going over a couple of examples. You get them all in your GitHub. They're all commented, so you can follow along. I just want to show you the result. With this structure, you can basically, let me make this a little bit bigger. You can basically redirect streams. And you can use this structure multiple times. So in this case, I'm redirecting stream number 6. If you look up in this table, 6 would be the right host stream. You can redirect that to the 1 stream, to the output stream. Likewise, you could take stream 5 and 4 and 3 and do different things. You can send them to null or in a file, or you can send them to 1. And now the trick now is that you can use a for each object to analyze your stream and separate those objects. You can say, hey, if this thing that comes from my command is a information record, then it comes from right host, then I can log it. And if it's not of this type, then I pass it on. This way, this filter you can add after each and every scripts and functions that use right host, and your right host messages would be filtered out and could be written to some database. Let me show you how that works. Okay, let's see. Here is everything isolated so that you don't have to think about ugly code like this. T-info. And here's how it works. I have any function or script that uses right host. I redirect the host channel to T-info and give it a name of a variable where I want the host messages to end up. This is just a name of any variable. This variable doesn't exist yet. This will be created. So when I run this now, okay, I have to define T-info, which is basically why this should be in a module, so you can't miss it. Okay. Now let's do it again. T-info. Where's my code? Oh, here. So I'm running it now. As you see, only the output channel is emitted to the console. Anything else is filtered out. My right hosts are filtered out. They are now in my logging data. They are now in here. They are my messages. And when you look at those messages, they appear to be a string, but they are not. They are info objects. So when you really look at those, they contain much of what you need for your logging. They tell you the message, when it was created, what your process ID is, and what the username was that issued that command. So that might be interesting too. There's so much more in this GitHub because I was sort of playing around and I knew it wouldn't fit into this time format. But so if you want to go there, all you need to know is this URL. What would be the best way to give it to you? Do you want to? I need to do one thing though. Wait a minute. Ooh, because currently, after the talk, you need to give me 5 more minutes so I can change it from private to public. But then you can go there.
And you will put it in the PSConfEU repo.
Yes, I will put it into the PSConfEU repo as well. That's good. All right, so we have about 2 more minutes. Any questions about ScriptBlocks that you may have? Or what I would really like to know is, how do you feel about sessions that take a generic item like ScriptBlocks that are part of the language and make it a session topic? Is that okay? That's what I want. Okay, I just don't want to bore you. That's the important part. All right. So thank you very much, and see you soon. Thank you.